And welcome back. I'm going to call this part 2 because we're already over an hour in editing. I just want to get right back to this. There's only a few components left to put in, so let's just get to it. In terms of low profile, and in terms of the connections to the outside world, the power and the buzzer going off to the side of the board and triggering something, we'll deal with that in a separate video. I just want to get this up and running and figure out what these 3 buttons actually do, because there's only so much information available. So in terms of height, actually I think the buttons are the next thing. Now if we look at the buttons, if I can do it without dropping them, there are two pins that are closer together on each side and further apart in the other dimensions. So that makes it so you can really only install this one way. And I believe the way these are, oh wow, I'm looking at that, it looks almost like, well, I'm going to attempt to put this in and we'll tell you what I find. What I'm finding is that these two are not the right distance apart. Let's try it this way. And they're not the right, oh, don't tell me these are the wrong buttons. Wow. Alright, I'm not giving up yet. I got 2 there. It looks almost like, wow. I need to get my glasses to see what I'm doing. Part of the problem I'm having is making better light for you makes worse light for me. So, still something to figure out with these videos. Alright, let's try again. If I can get 2 of them. Yeah, the hole spacing on this is terrible, but doable. You're going to have to kind of squeeze the legs together in one direction. There, it's going in. Let's make sure we're not just bending pins, which is exactly what I'm doing. I got 3 out of 4. And that might make a difference. I'm going to have to pull it out and straighten the pins. So this is where the pliers come in handy. These are pretty much just normal needle nose pliers. They're not some special electrical thing. The snips, you can buy side cutters on eBay for fairly cheap, although don't expect them to be the highest quality. You probably want to start with the lesser quality ones while you're getting started on these things. That way, I mean, sometimes you probably, if you go on eBay, you can buy them in like 5 packs or something like that. Let's see if we can't get this one in now. Alright, let's send it home, make sure all 4 pins are actually sticking through. Yep. Okay, that's all 4 pins sticking through. So it turns out, if you have the same board, because different sellers may have different, the boards may be designed slightly differently, but being that, let's get my pointer here, that you've got these 2 here are closer to each other, and going this direction, they're further apart. When you look at the board, it looks like a square. It looks like they're evenly spaced, but they're not. In this particular case, going this direction, sort of top to bottom the way I'm doing it now, is shorter than going left to right. So you need to kind of match that up. Once you match that up, you can get the switch in. But what I'm going to do with the second one is I'm going to go ahead and just straighten these pins. They're designed so they kind of spring on you and snap in there, but being that way and being the tight tolerance that it is, it just bent the pin on me. So basically you want to get 2 pins in first. The spacing's not perfect. And then you want to carefully use your fingernail, my thumbnail in this case, to try and line the pin up with the hole. Oop, I may have gone too far on that one. I'm going to use the pliers to rescue it, bring it back. You don't want to bend them too much, or you'll break them off. So it wasn't my choice, these particular switches versus this circuit board. So that's 2 of them. I'm going to go ahead and get the third one on there, and I'll solder it up and I'll be back. Alright, I don't know if you caught that towards the end, but I started realizing that rather than doing all 4 at the same time for one switch, it's probably better to pick a leg, do that one, do the second switch, do the third switch, then go back to the first switch, do a different leg. That way you're spreading out the heat that you're putting into that component. But there we go, we've got 3 switches now mounted. Let's get, before we dive into the displays, I'm going to try and put this buzzer on there. Now this is an active, after staring at the circuit, I'm realizing this is what they call an active buzzer. It really means that the sound circuitry, the thing that determines what frequency, what pitch it is making a noise at, is built into this unit. So you don't need the extra circuitry to determine what frequency, but it also means you only get the frequency that's on here. A passive would be basically just like a regular speaker, and you would have to determine the circuitry to actually make the sound, if that makes sense. All that we really have for circuitry on here is one of these transistors is an amplifier for to provide enough voltage, ultimately. Transistors can be used as amplifiers or as switches. So now that I think of it, it's acting as a switch. It's turning it on or off. And that is why you can have something coming off the board that is in parallel to this, so that you can trigger something else. But I've also noticed that on this board it is marked that there is a plus sign here for this. I'm going to make sure we're still in frame here. There's a plus sign there, and if you look carefully at this, you'll see that hanging off this tab is a plus sign. I leave these tabs on in general. Sorry, side note, I leave them on because this actually muffles the sound, because these things can get rather loud. If you pull it off, actually I've got one sitting on the edge of my mat here that I pulled off of another one. But getting back to the point of the plus sign, here's a plus sign here, there's a plus sign there. You want to match them up. If I just flip this over in the same orientation, you'll see that there are 2 pins here. So that's what I want to do, is stick that in that orientation. So this is a polarized component. It is possible to install it backwards. That is why I'm making that point. There we go. That is now on. We can solder that up nice and quick. Heat it up, add the solder, heat it up, add the solder. Okay. I'm going to clean that up slightly. That's got that. That leaves us with the displays and actually putting the chip into the socket. And hooking up the power. Now when it comes to the displays, I want to look at something here. Yeah, I think Yeah. It may be a little hard to see when you first unpack it, but there is something you can peel off the front here. And this would have obscured the light a little bit, so if you want to leave it, you could. I don't think this is going to get heated up enough that that film is going to be an issue. But I wanted to make sure that I got it off. And now, also, if you look carefully, you will see that I have an 8 and I have a little dot. I have an 8 and a little dot. Those dots are the decimal points if you're building like a calculator display or something like that. These are universally used for things like clocks and calculators and different things. It's called a 7-segment display. This is a 2-digit 7-segment display. I'm not sure if it's common anode or common cathode. But if you look carefully, oh, now that's interesting. On the board, it would appear that what they're showing is the decimal point being to the left, not to the right. But I'm going to assume that they want the decimal point down below, because if you think about it, decimal points in numbers end up being on the lower part, not the upper part. So it would, even though I think those are oriented wrong, or maybe they got the figure that they used to actually silkscreen this onto the board may have been actually backwards when they put it on. So let's see if we can't just line all those pins up. And you don't want to push too hard until you know you got them all lined up. Once you got them lined up, you push it in, and now I can start soldering this. Like with some other components, what you actually want to do is just solder one pin first. That creates the mechanical connection. And then you want to make sure, you want to heat that up again and push from below to make sure that it's fully seated. Which I just heard it snap a little when I did that. Which meant it wasn't 100% seated. So now it is. I can finish soldering this one. I will put the other two on, and I'll be back in a moment. Alright, that's got everything but the power connector in there. A couple of things. One, it seems almost like the legs are made of a different sort of material where it kept bridging on me. I'm not sure what the deal was with that, so watch out for that if you have the same kit. Also, I didn't pull the, I didn't do the peel off these two. I want to be able to see what the difference is between them, but also it allowed me to, when I put it in and pushed it from underneath to make sure it was seated right, I'm not worried about getting grease or anything into the into those little openings there. If you were to actually feel it, oh, I take it back. Probably wouldn't be as much of an issue. Some of these displays, it's actually open to the LED that's down below. But in this case, it looks like there is not just the part that you can peel off, but there's an additional clear plastic part on top. That said, what we're left with is the power connector. I'm not going to worry about the other connectors right now. When I get the power connector on, I can also just bypass this and put the battery pack directly onto it. But for the moment, what I'm going to do is go ahead and put the power connector on because it's just a little bit neater. And that is, you want to have these openings here facing the outside of the board. This is not polarized. You could put it any other way, but then how are you going to put your wires into this connector? This is where they actually go, so you want to have that facing the outside of the board. So I'm going to go ahead and put that on. And once again, the hole spacing is questionable. Doesn't... My pins are not bent. This doesn't want to go in. I don't want to force it. I'm giving it gentle pressure, trying to get it to go in, and it is not going in. Okay, now I can see that it's bent, but that's probably from me. Let's bend this one back out a little. Oh, that's more than a little. Okay, they're slightly splayed out. Hopefully that will help. Is there solder on the underside of the board? No. That's not the issue. It's just fighting me, that's all. I can see the two pins trying to come through. So maybe what it is, it's not the hole spacing, but the size of the holes. This does appear to be the right connector. Alright, this was a poor choice on the part of the whoever assembled this kit, so I am going to bypass that. We're going to go straight to the battery pack. Now, there is a positive signal here, and that should be the red wire for the battery pack. Let's confirm that actually. Yeah, I can see that the red wire is going to not to a spring, but to one of these rivets here. And that would match up with the battery. It would match up with the button on the top of the battery. So that's what you want. I'm going to solder that in. Let's hope I can get that little wire to go through the hole. There we go. Now this is going to be fiddly. I'm going to have to kind of hold this, do this a la Big Clive here. If you have a set of helping hands, that might make it a little easier. Otherwise, you're kind of at the mercy of the stiffness of the wire and hoping that it'll hold. Let's see if I can coordinate this. Once you get the solder there, you should be able to check the wire and maybe adjust it just slightly. Yeah, that's better. I got to do that again for the black wire. Maybe I can sit this down on top. Now the problem is the black wire just came back out again. Another possibility is if you got some tape, you might be able to tape it down to keep it from moving around on you. Whereas the various UK YouTubers that do the electronics blue tack, nope, it came back out again. So I'm going to have to do it a la Big Clive there. Just gotta... I'm thinking the helping hands... Well, alright, let's get the helping hands. This is what I'm talking about. Something like that, where I can, in theory, clamp onto the board with one of these. I'm going to have to adjust it to point in the right direction. Then get the black wire up under there. Let me get the black wire clamped. Nope. And so these hands are adjustable. You can do various things. So I'm going to pull it in. And the idea is to make it just stable enough to actually be able to do the soldering. This really should not have been this fiddly. And I cannot see where I'm aiming the wire. Alright, we'll get this. I'm going to unclamp this. Get the wire to poke through first. There we go. Wire is through. Gotta hold it. Oh, it just came out again. I know. Why didn't I think of this before? Let's clamp both the red and the black together. Put something underneath. Alright, that's a little iffy. Let's hope I can get it, or I'll be sucking the solder back out of the hole when the wire goes away. Who would have thought the last step would have been the hardest? Alright, I got the wire in, but it's not really good. But what I can do now, much like I've done to the other components and kind of resetting them, is I can reheat the solder and push the wire through. Oh yeah, that's better. Well, except that there's not enough solder. There we go. We're in. Put away the helping hands. And in theory, we should have everything we need to start putting some batteries in and see if this thing lights up. There's 1, 2, 3, 4. That's what, 4.8 volts, 6 volts, and this last one will make the final electrical connection. 4.8, 6, that's be 7.2 volts going through a 5 volt regulator. And we got nothing. Let's see if we need a switch. Did I get the voltage right? Well, that's anticlimactic, huh? It's possible one of these batteries is bad. Let's just try swapping out the last. Oh, I know what's wrong. Ah, silly me. Let's pull one out that's easy. I forgot to put the chip in. So basically this is like a computer, and if the computer doesn't have a brain, nothing happens. So let's put the chip in. Now I need to make sure I install this correctly. If you remember from before, there is a little notch here, and that corresponds to the little dot on the chip. Let me see if I can bring that up, and hopefully that'll focus. So I need to line those up before I put it in. Also, the legs are splayed out maybe a little bit more. I want to bend them in just ever so slightly. I don't want to go overboard with this. I don't want to bend the chips in on themselves. I'd hate to destroy the processor before we actually finish this. Okay, there's my little notch. And just line up all of the pins with all the holes. And note that I disconnected the power before I did that. Don't need some stray signal happening and doing some damage. These chips should be fairly hardy. There's probably some people out there looking at this going, oh my god, he's not wearing a strap. An anti-static strap is good when you're dealing with electronics. I'm just winging it here, not worrying too hard. Okay, now I got it all lined up and I pushed it in. Let's try that again. Let's see if this lights up. Yes! And you can see, well, for some reason it's starting at 10 minutes and it's counting the seconds up. So that's a good thing. Let me move the battery pack over a little so it's a little bit more obvious what's going on. Let me actually get rid of that problem there. Little thing off to the side. Alright, so we're gonna, you know what? I think I might separate this out to another video to figure out how to set the clock. This is the build done, and once you get to this point, if this doesn't light up with the chip in it, then you want to go and flip this over and examine all your connections, every one of them, carefully. In fact, I'm actually looking at one that, yeah, it's okay. Check them all, make sure that they're connected properly. Take the disconnect the battery, or pull one of the batteries out. That'll disable the power, and go through and make sure that everything is good and that you don't have any solder bridges. That's the first thing to try. If you can't find the problem there, maybe I'll do a video on trying to troubleshoot what's gone wrong. There's so many things that could have gone wrong with this, and I'm just very, very lucky that this is working properly. So with that, I'm going to wrap this portion of the clock build videos up, and we'll come back to actually figuring out how to set the clock. And I think what I'm going to do is experiment with it, and then I'll come back with actual knowledge of how it works rather than just experimenting on video. That way it'll be reasonably short. Thank you so much for watching. Sorry it took so long to get through this. This is not the simplest project we could have done, but we got through it. It is functional. Thanks again for watching.